This video is made under the project presentation of the subject IT 619 Design of Software System, instructed by Professor Saurabh Tiwari. This project demonstrates the Webmail application. Thanks to Ms. Tripti Padhyay and Mr. Zubin Mola for guiding us throughout the project. This system is made by Aditya Saxena, Chintan Sangvi, and myself Bharat Parasya. Now, I would like to explain about this webmail system. Humans are also known as social animals. Why? Because humans like to communicate. We like to stay connected, and for being connected, we communicate. There are a lot of ways to communicate. In olden days, the communication used to happen via mail, the letters through post offices. As time evolved, digitization encapsulated the mails. They were turned into emails. Emails were good for instant communications of message. In a way, it became formal communication. Talking about emails, we can have it in two forms. First is standard emails. Remember those desktop clients used for sending and receiving emails? They were big, heavy softwares to do this simple task, like Outlook or Thunderbird Mail. Second and most common way is webmail. These mail services can be accessed via thin clients like browsers. Generally, they are free to use and so they are widely used. Many big companies have their own webmail systems like we do have in DAIICT. If you have noticed on the introduction slides, having a local mail system is really beneficial as it is faster to access and can still work if the internet is down as it resides within the premises. For now, DAIICT has a webmail server that serves the purpose. It is spread over a distributed server using Zimbra collaboration suite. You can check the software out in the link from the description below. It's okay, I know going through this theory is a bit boring. Why are we doing this project? So, the motive behind doing this project is here at DAIICT, each and every news, announcements, or any information that is passed is sent by webmail. May it be cancellation of lectures or it be your presentation in the next hour. All information is sent on webmail. To check webmail, we need to open up the browser, log into the system with the credentials, and retrieve the updated information. It seems normal, right? But what if you had to do that twice a hour? It is tedious. So we wanted to send it to the phones like push notification. But that is not possible with the existing server. So we tried to make a pull based notification to solve the problem. It notifies us when a new mail comes in within a minute as if it was an SMS. For understanding webmail, we have created this series of diagrams to understand the working of webmail so that the companion mobile app can work seamlessly between them. In design of software system, the system is explained via modeling diagrams. For example, use case diagrams, activity diagrams, sequence diagrams, class diagrams, collaboration diagram, deployment diagram, etc. But for creating our first diagram, use case diagram, we need to identify our functional requirements. Functional requirements captures the intent behavior of the system. This behavior may be expressed as service, task, or functions that systems is required to perform. This white paper lays out in important concepts and discusses capturing functional requirements in such a way that they can drive architectural decisions and be used to validate the architecture. Features may be additional functionalities or differ from basic functionalities along some quality attributes such as performance or memory utilization, but they are part of non-functional requirements. Use cases are first diagram in modeling language. A use case defines a goal-oriented set of interactions between external actors and the system under consideration. Here it is webmail. Actors are parties outside the system that interacts with the system. An actor may be a class of user, role user can play, or other systems. UML distinguishes between primary and secondary actors. A primary actor is one having a goal requiring the assistance of the system. A secondary actor is one which the system needs assistance. Let's see the functional requirements of webmail systems. Let us go through the webmail systems functional requirements first. First of all, the functional requirement is registration. Second is login. Another is group participation. That is, a user must be a part of any group so that it belongs to a certain group every time. That is generally used as a batch. Receive and response of email systems. Task manager. See, user can add, update, delete their task. Uh, Contact management. A user can manage their contact by adding, updating, or deleting the existing contacts. User can be able to back up from the system, right? So these are the main functional requirements of the system. So now let's have a look how we will transform these functional requirements into use case diagram. See, first of all, what we will do is we'll club all the related activities into one single use case. Say, for example, registration. Registration or any updation in the accounts will be done by administrator. That would that is shown in this use case. Say, user management by admin, right? Another is login. Any user can log into the system. So and we have kept this into a use case named login. We have made this group participation thing. Groups are created as and when created, updated, or deleted as and when they are registered, means students are registered within them. So we created a use case for group management. Receive and respond to emails. Again, this all the things is related to mail, so we have made a use case of mail management, which includes sending a mail or saving the mail into draft, or even deleting mails into mails from the mailbox. We now have task manager. uh, Task manager is generally is divided into two parts, that personal task and the group tasks. Say, group tasks, for example, group as in collective, collective of individuals have a lecture at morning 9, so they'll these would become their schedule. So admin will manage that schedule, means the change in the schedule will be handled by admin, uh, and while the personal tasks would be handled by user. So user can handle his personal tasks. Say, a user has a meeting of some club or a committee at evening 6. So it won't be the case that the whole class has a meeting on that time. So user can add individual tasks. So we have created two different use cases for this thing. Another the next use case sorry next functional requirements is manage contacts. We have made contact management use case for the same, right? Now the next functional requirement is backup. So here is the backup use case. User can send all the data, say all the mails, to a different mail server for backing them up, or he has an option to download all the user data as in format of zip or any other compressed file format. So now let's talk about the use case. Here in use case we have specialized admin from the user. Generally it is not the case. Why? So admin is cannot do all the tasks in every system. Say we have employee management system, and there are certain tasks that only employee can do. So we cannot make a same user as a admin that who can do all the tasks that an admin does. That would be incorrect. But uh, in this system it makes sense. Why? Because admin can also do all those stuffs that a user can do. Say admin can also log in. He also has a mail account associated with his account. He can have his personal task. He can have his personal contacts. He can back up his data, right? Additionally, he can manage users. He can manage schedule of different groups, and he can even manage groups as well. So here it makes sense to specialize admin from the user, because user has all the functionalities that the user does.
Hello, my name is Chintan Sangvi. Here I explain about the activity of Webmail application. Are you know what is the activity diagram? Activity diagram means graphical representation of basic flow and alternate flow of use case. Now I explain one of activity of our system. Most widely in our system, admin can manage account, manage schedule and manage group. So I prefer to explain about the manage group. In manage group, first we see the session of admin's login. If admin is not logging, then we provide the facility of admin login. After login, admin can do any activity of group. As we see in this diagram, admin can create the group, update the detail of group, and also admin can delete the detail of group. After completing any of one activity, it goes to the store data and then it moves to the activity. Now I explain one activity of user. User can backup his or her data. First we check the session of user's account. If user is not logging, then we provide the facility of login. After login, we choose the backup method. There are two backup methods. First one is directly generate the backup file. And the second way is we enter the mail ID and all mail forward to that mail ID. So here I explaining about the activity diagram. Now we are moving to sequence diagram. Sequence diagram shows object interaction arranged in time sequence. The first question is always raised. The question is how we create the sequence diagram based on an activity diagram. So first I explain about the one sequence diagram, that is manage group. In sequence diagram, it is collection of so many objects. Here you can see that admin is an actor, group page is a boundary object, and the DB controller is a part of a controller object. So as we see in a diagram, admin can add group, update group, and also delete the group. The admin request to the group page for managing the group. So admin can perform various tasks in a group. Here we are using alternate flow. So admin can do only one thing at a time. Now we move to another sequence diagram. The another sequence diagram is backup data. In backup sequence diagram, you can see that the user is an actor, the data page is a boundary object, and DB controller is a part of a controller object. Here the user can send the request backup for the data page. Data page send the message to the data controller for forwarding all the mail. Data controller pass the message get detail to the database, and data controller send all the data to the another server. Else, the data page send the message for downloading the data to the data controller. Data controller get the detail of the all mail information, and it can be directly passed to the user because it is a physical data of the user. So now we are moving to the another class diagram based on a sequence diagram. How we create the class diagram? So I would like my another teammate for explaining about the class diagram.
Hello, I am Aditya Saxena and I am going to talk about creating class analysis diagram from the sequence diagram with an example from our system. The main problem for constructing class diagram is in finding the right classes. We address this problem from two perspectives and construct the class diagram in two work steps. Firstly, in top-down analysis, classes are found first on the basis of general understanding on the subject matter, domain knowledge, verbal descriptions of the area of application, and user understanding are important sources of information. In this way, a basic structure of classes can be formed for most IT systems. Secondly, in bottom-up analysis, the classes are found mainly on the basis of inputs and outputs of the system. Already existing inputs and outputs like screen forms and paper forms are important sources of information here. For bottom-up analysis, we first list required queries and inputs. Here, the individual queries and inputs of the system are more important and has to be identified first. Which queries and mutations occur in a use case is already drafted in the use case sequence diagram. Secondly, we formulate queries and inputs. Here, in order to create individual class diagrams for the individual queries and inputs, we first need to define how they look. Complex query results or inputs are collected and drafted. Next, we conduct information analysis. In information analysis, for each query or input, a small class diagram is created on the basis of the existing classes. This is achieved by modeling the drafted inputs and outputs of the system in sequence diagram. We use this sequence diagram to generate a class analysis diagram. It's a direct mapping. Basically, each swim lane represents an object of a particular type. So they represent our classes. Furthermore, messages between swim lanes, depending on the type, represents calls to operations. We'll also get the parameter and return type, so we can have complete operation signatures. Now next, we see one example of creating class diagram from sequence diagram. We will look into manage group sequence diagram and create manage group class analysis diagram. So firstly, manage group activity is undertaken by an admin. If we look at the sequence diagram, we have an admin, a group page, a group controller, and the database. We model them all into the analysis class diagram as classes and put their appropriate calls as functions. To manage a group, an admin selects to manage group on the group page. So we have manage group method in the admin class. Next, the group page creates a database controller based on the admin selection, and the controller sends appropriate instruction to the database. So we have all the appropriate methods such as add, update, and delete groups in the controller class. And after this, the database performs the instruction for which it needs to set and get data. So we have set data and get data method in database class. And at last, an acknowledgement is received on group page and the activity gets completed and our class diagram for manage group is completed. Hello, I am Aditya Saxena and I will explain the class diagram of our webmail system. Firstly, a class is a classifier which describes a set of objects that share the same features, constraints, and semantics. A class is shown as a solid outline rectangle containing the class name and optionally with compartments separated by horizontal lines containing features or other members of the classifier. The top compartment contains the name of the class. It is printed in bold and centered, and the first letter is capitalized. The middle compartment contains the attribute of the class. They are left aligned and the first letter is lowercase. The bottom compartment contains the operations the class can execute. They are also left aligned and the first letter is lowercase. Class diagram is UML structure diagram which shows structure of the design system at the level of classes and interfaces. It also shows their attributes, constraints, operations, and relationships like association, generalization, dependencies, etc. The class diagram is the main building block of object-oriented modeling. The classes in a class diagram represent both the main element, interaction in the application, and the classes to be programmed. We have already created individual class analysis diagram of our system, and now we first need to consolidate class diagrams. Here the question arises, how does everything fit together? In this step, the individual class diagrams have to be consolidated into one cumulative class diagram. Here, inconsistencies are discovered and corrected. Applicable questions are there classes in the individual class diagram that have different names but represent the same thing? Are there multiple relationships in the individual class diagram that have the same meaning? Are there attributes within classes that are named differently but have the same meaning? In fact, when all individual class diagrams are being consolidated to one cumulative diagram, these questions almost pose themselves. Once inconsistencies have been recognized, they can usually be corrected easily. If we use the classes found during top-down analysis for modeling the drafted inputs and outputs, overlaps and conflicts during the consolidation of the individual classes diagrams should be limited. And at last, we verify the class diagrams. Here, the question which arises is everything correct? The completed class diagram in the structural view can be verified by answering the following question. Is the class diagram complete? This question is answered in interaction view. In the interaction view, we will show how the class diagram can be used to answer all required queries of the system. If this is possible, the class diagram is complete. Is the class diagram correct? Is the next question. This question about correctness is a little bit more difficult to answer. It shows that intensive collaborative reading of class diagrams together with the knowledge carrier will bring to light more mistakes. In addition to that, the class diagram can be tested for suspect structure pattern. The best way to do this is with a suitable tool. Here we have collaborated all individual class diagrams from the earlier stage and created class diagram for our webmail system. So we have classes like user account, admin account, mail, attachment, task information, contact information, group, schedule, schedule event. And the relationships and multiplicities has also been identified and shown. So a user account can have 0 or more contact information. It can have 0 or more task information. It can have 0 or more mails. Also, a user account is a member of one or more group. Groups shows the belonging of a particular user account. For example, a user account of student will belong to a particular batch, and a user account of a faculty will belong to a faculty group. Webmail system by default has one admin user account. Admin is a special user which can add or delete a user account, manage group, and manage schedule of group. Every group has 0 or 1 schedule. Every schedule has 1 or more schedule event. A mail may have 0 or more attachment. We have identified attributes using top-down analysis. User account has attributes like username, which is unique, which will also be used for mailing him. It also has a field of password, which will be used by the user for logging into the system. Attribute corresponds to the first name of the user. The last name attribute corresponds to the last name of the user. The account status shows that if the account is currently active in the webmail system or it has been deactivated. The login status shows that if the user has logged into the webmail system or not. Size quota corresponds to the quota allotted to the particular user. Also, a user will request login, manage task, manage contact, and request backup. Now we see mail. In mail we have sender ID, which is the ID of the user which has created that mail. In the receiver's ID is the ID to which the mail address. Subject is the subject for the mail, and description is the text which will be sent by this mail. Date is the date of creation of the mail, and mail size is the size of mail, which includes the size of text and plus the size of attachments. In attachment we have file name, file type, file, and size, which is the size of the file. Contact information will have first name, last name, email ID, address, etc. Task information, we have task name, date created, which is the creation date of that task, alarm status, if the user wants to set an alarm for the task. Alarm time is the time at which the alarm will ring, and note is the text which will be stored for the task information. So that's it.
OCL, Object Constraint Language. Do you know what is OCL? OCL is a declarative language for describing rules that apply to unified modeling class. Now we see the example of OCL. Example 1. User must be in at least one group. Answer. Context user inv self dot belongs to size greater than equal to 1. Here inv means invariable and self means object of user. Now we are moving to example number 2. File type must be in PDF or zip. Answer. Context mail inv self dot attachment dot file type equal to dot PDF or dot zip. Now we are moving to the last example of OCL. Password must be at least 8 character long. Answer. Context user account inv self dot password dot size greater than equal to 8. So now we understand about the OCL. OCL is not written in class diagram, but it still shows the constraint of object. Now I would like to my another team member for describing another part.
Design patterns are used to solve the daily problems that occurs in creating the software system. This type of solution has been used and tested in scenarios so that it can guarantee the solution of the problem. Here in this system, we can use 3 design patterns. Most common these days is MVC, Model View Controller, used to differentiate between views and working of the application. Second pattern that applies in here is singleton pattern, which is also popular these days, creating only single object of the class to accomplish all the tasks. Here, database controller would be the singleton class. Third pattern that applies is observer pattern. Here in Webmail system, when a mail is sent, all the users are notified about the same. The user which are addressed by the mail keeps a copy of the mail and rest of them discards. And that concludes the project. Thanks everyone, without whose support this project won't be possible. Thank you.